Good morning, everybody. Welcome to the more advanced problems of Target 1D, where I could solve equations involving rational exponents. So this part is going to be talking a lot about solving equations, which is a very important skill in math. So I want to briefly review a couple of things. So here's some just kind of tips, is that there must always be an equal symbol at every single step you're solving. In order to maintain equality, anything that changes one side of the equation must be done to the other. So on the two different sides of the equals, if you do something to the one starting side, you have to do something to the other side too. That's the nature of equality. I always think about it as siblings, right? You know, if you get a candy bar and your sibling doesn't get a candy bar, you're never going to hear the end of it. And the final thing that we need to keep in mind is you can undo arithmetic by performing the opposite of that arithmetic. So here are your different operations that you're familiar with and their opposites, right? So if you add something, you can undo that through subtraction. If you multiply something, you can undo that through division. If you raise something with an exponent, you can get rid of it with a radical. So let's look at an example of something that'll be a little more advanced than what we did the other day. Here we have 3 to the x over 2 minus 7 power. It's a bit of a mouthful. And equals 27. So the other day we looked at, are the bases the same? No, these bases are not the same. The 27 is very different than the 3. So what we're going to do is rewrite 27 as 3 to some power, right? So 3 to the first power is 3, 3 squared is 9, and then 3 to the third power is 27. So what I'm going to do is I'm going to rewrite this as 3 to the x over 2 power minus 7 is equal to 3 to the third power. Once we get here, we can set the exponents equal to each other, right? They have the same base, so the exponents have to be equal. So x over 2 minus 7 is equal to, the exponent here is 3. So again, same basis, the exponents have to be equal. So now I am going to undo the arithmetic operations. And to undo that, I'm going to go in this order, right? So there's an arithmetic operation of subtraction. So I'm going to do its opposite, which is addition. So here I'm going to add 7 to both sides because there's a minus 7. I want to get rid of that. Remember, your goal is to get x by itself. So if I have negative 7 and then I add 7, that's 0. So those cancel each other out, actually. I get x over 2 is equal to, again, I'm keeping that equals in every single step here, 3 plus 7, which is 10. Okay, so now I have x divided by 2. I want to get rid of division. So the opposite of division is multiplication. So instead of dividing by 2, I'm actually going to multiply both sides by 2. So 2 times that, and then I'm going to multiply, 2 times 10 here. So if I multiply 2 and then I divide by 2, that leaves me with 1. So it just leaves me with x. And then here I have 10 times 2, which is 20. And that would be my answer for the first question here. Let's look at another one. Here we have 2 to the power x over 3 minus 5. And it's equal to 16. Well, I'll go ahead and spoil it for you. I'll save you the time. 16 is 2 to the power 4. So here we have 2 to the power 4. So I can rewrite these, their exponents equal to each other. I'm going to draw a line here so we kind of get the other problem out of the way. So you have x over 3 minus 5 is equal to 4. Okay, so I'm going to add 5 to both sides, plus 5. Right, undoing subtraction is addition. So you get x over 3 is equal to 9. And now to get rid of the division, I'm going to multiply. So I'm going to multiply both sides by 3. Those 3's go away. And then I'm left with x is equal to, let's write it over here, 9 times 3, which is 27. And there's some of your more advanced solving math equations, ones where you have to both add or subtract something and then multiply or divide something.